Have you ever imagined a tank with wings, or a jet without engines? Throughout the 20th century, brilliant minds around the world built flying machines that defied logic, physics, and expectations. Some looked ridiculous, others were pure genius. But one thing's certain, they all changed the future of flight forever. Buckle up for a journey into the skies of madness and innovation. You won't believe what the Soviets built during World War II, a tank that could fly. The Antonov A-40 Krilia Tanka fused a T-60 light tank with enormous glider wings and tail. Weighing nearly 15,430 pounds, it had no engine and relied on airborne towing. It was an audacious attempt to deliver armored firepower straight into enemy zones by air, a wild concept that straddled genius and madness. The goal was rapid airborne deployment of a combat-ready tank. With a wingspan of 59 feet, it could glide as far as 8 nautical miles once released from a towing aircraft. After landing, the wings would detach, and the T-60 would roll into combat under its own power. The Soviets believed this hybrid would bypass terrain limits and strike deep into inaccessible fronts. But physics had the final word. No bomber available at the time could generate the thrust to tow such weight into the air. Even the massive TB-3 struggled to lift off. Drag was overwhelming, control was erratic, and landings damaged essential components. Despite a successful test flight, the program was grounded. Too dangerous, too heavy, too far ahead of its time. Still, the Antonov A-40 Krilia Tanka remains a symbol of Soviet engineering daring. Its concept influenced later thinking in airborne armor deployment. Museums preserve replicas as reminders of Cold War extremes. While the Soviets put wings on a tank, American designers were drawing blueprints for something just as bizarre, an airplane that looked exactly like a giant flying umbrella. In the early 1930s, American skies saw one of the most bizarre aircraft ever imagined. The Nemet Parasol featured a massive circular wing mounted high above a slender fuselage, making it look like a flying umbrella. It was powered by a Continental A-40 engine, generating just 40 horsepower, reaching a top speed of only 45 miles per hour. Or 72 kilometers, but its strange appearance hid revolutionary low-speed capabilities. The aircraft had incredible short takeoff and landing performance for its time. Built from lightweight tubing and fabric, the Nemet Parasol could lift off in a few dozen feet. Its circular wing offered remarkable lift, even at crawling speeds. At a time when aerodynamic theory was still maturing, this American experiment defied expectations. Crowds watched in disbelief as it performed near vertical landings in public demonstrations. Test flights confirmed its outstanding stability at extremely low speeds. Pilots reported smooth, controlled handling even in gusty conditions. The Parasol wing generated lift so efficiently that it nearly eliminated the risk of dangerous stalls. Without needing complex control systems, it flew naturally and intuitively. Its odd shape masked one of the most docile flying behaviors ever recorded in experimental aviation. But no matter how well it flew, the Nemet Parasol never reached production. Its unconventional looks scared off investors, and public perception labeled it a curiosity, not a contender. Still, its aerodynamic legacy influenced future stall aircraft designs. Hobbyists have built working replicas to preserve its memory. Meanwhile, as Americans explored soft landings and peaceful innovation, post-war Germany would launch jets into the air vertically. In the late 1960s, Germany introduced one of the most ambitious jet transport projects ever seen. The Dornier D O 31 used 10 jet engines, 2 Rolls-Royce Pegasus for forward thrust, and 8 vertical lift engines for takeoff. It reached speeds of 400 miles per hour, or 640 kilometers. It blended transport, jet propulsion, and VTOL capabilities in a single machine that looked decades ahead of its time. The complexity of this German aircraft stunned Cold War engineers. Its 10-engine system relied on advanced computerized control for thrust balance and directional shift. The vertical to horizontal transition occurred via precisely timed redirection. Designed to carry 36 fully equipped soldiers, it promised unmatched tactical flexibility. Public demonstrations created media buzz with their science fiction visuals. Flight tests confirmed its raw power and vertical lift performance. The Dornier D O 31 lifted heavy cargo from spaces helicopters could never reach and then cruised at jet speeds. However, running 10 engines burned enormous fuel and required constant maintenance. Despite flawless tests, the aircraft's operating costs and logistical needs far exceeded military budgets of the time. Eventually, the Dornier D O 31 was cancelled, but its legacy lived on. It remains the only fully functional vertical takeoff jet transport aircraft ever built. Museums in Germany preserve its groundbreaking design. Modern VTOL concepts continue to study its architecture. As Germany reached skyward with futuristic jets, Italy had once experimented with a flying tube that changed aviation propulsion forever. Prepare yourself for the strangest flying machine ever built. In the early 1930s, Italian engineer Luigi Stipa created the Stipa-Caproni, an aircraft that looked like a massive flying barrel. Its entire fuselage acted as a hollow duct enclosing the propeller, generating amplified airflow. Powered by a de Havilland Gypsy engine with 120 horsepower, it reached just 81 miles per hour, or 130 kilometers, but rewrote propulsion history. The genius of this machine was in its cylindrical shape. The fuselage worked like an early ducted fan, increasing thrust through internal airflow compression. Though it resembled a flying pipe, test pilots noted incredible in-flight stability. Aerodynamicists of the era laughed at the bizarre appearance, not realizing they were witnessing the seed of future jet engine design. Stipa's idea was so far ahead, it was misunderstood by nearly everyone. Test flights revealed fascinating behavior. Despite its slow top speed and limited performance, it offered gentle, predictable control under all conditions. Pilots described flying it as gliding through a quiet tunnel. The enclosed propeller reduced noise and vibration. Remarkably, it handled turbulence better than conventional planes of its time, thanks to its internal ducting and streamlined body. Modern engineers now recognize the Stipa-Caproni as the forefather of ducted propulsion. Its influence is found in turbofan engines and blended body airframes. Preserved in museums as a monument to radical design, it inspires aerospace engineers to rethink what's possible. While Italy pioneered enclosed thrust, France was crafting an interceptor that looked straight out of a science fiction novel. In the mid-1950s, France unveiled one of the boldest aerospace experiments in aviation history, the Leduc 022 featured a revolutionary dual-engine system combining a turbojet and a ramjet. Its cylindrical fuselage and circular air intakes gave it a science fiction look. Built to intercept high-speed threats, this aircraft reached over 1,000 knots, making it one of the fastest designs ever tested in Europe during the Cold War. Made with cutting-edge materials, the Leduc 022 reached speeds close to Mach 2, nearly 1,340 knots, and climbed rapidly through the stratosphere. Its aerodynamics reduced drag dramatically during sustained supersonic flight. Both engines operated simultaneously at high speed, with the ramjet offering extreme acceleration and power. It surpassed most American and Soviet interceptors of the era with ease. Test pilots reported staggering performance. Takeoff relied on the turbojet, but once at altitude, the ramjet ignited with overwhelming thrust. Acceleration was instantaneous, and the aircraft soared to extreme heights with stable handling. The Leduc 022 proved that France could compete at the top tier of military aviation. It opened the door for hybrid propulsion long before it became mainstream. Sadly, a fire during testing destroyed the only prototype. Military leadership shifted focus, and the high costs of development ended the program. But the technology pioneered here would later influence modern ramjet and scramjet systems. The Leduc 022 was decades ahead of its time. As France tested futuristic interceptors, engineers in Canada were building something that looked more like a flying saucer than an aircraft. In the late 1950s, Canada stunned the world by building what looked like a real flying saucer. The Avro Canada Visa 9 Avrocar had a perfect circular frame inspired by popular science fiction. It used 3 Continental T-59 turboprop engines, each generating 420 horsepower to drive a central lift fan. It promised vertical takeoff and forward flight without using any exposed rotors like a helicopter. This futuristic aircraft used an experimental Coanda effect propulsion system. Air was pushed downward through a circular duct to generate lift and directional control. The theoretical top speed reached 300 miles per hour, or 480 kilometers, outperforming traditional helicopters. It could hover, take off vertically, and then transition into high-speed forward flight. a revolutionary combination in vertical mobility. However, flight tests revealed major stability problems. The Avrocar struggled to rise more than 3 feet above the ground. Its directional control was erratic, and pilots found it nearly impossible to handle. The lift effect only worked properly near the ground due to ground cushion interaction. Once airborne, vibrations increased dangerously, and control became unpredictable, even for skilled test pilots. The project was eventually canceled after enormous costs and disappointing results. The complex Quanda system was simply ahead of its time. The joint Canadian-American effort ended quietly, and its documentation remained classified for decades. Today, the Avrocar is displayed in museums as a symbol of Cold War ambition and UFO-era imagination. While Canada chased flying saucers, Americans were testing something humbler, a flying military jeep with open rotors. In the late 1950s, the United States built an aircraft that looked more like a scaffolding rig than a flying vehicle. The Curtiss Z7, nicknamed the Flying Jeep, featured a tiny pilot seat surrounded by 4 exposed rotors mounted on tubular arms. Powered by a Lycoming G1340 engine producing 260 horsepower, it could reach a modest speed of 65 miles per hour, about 105 kilometers, but had vertical lift capabilities. Despite its crude appearance, the Curtiss Z7 was remarkably easy to fly. The 4 rotors gave it exceptional stability, and the open frame kept the aircraft lightweight. Pilots praised its intuitive controls and simple layout, which allowed even untrained personnel to grasp basic handling quickly. It could take off vertically without any runway and hover in place for reconnaissance or rescue missions in mountainous terrain. Field tests showed surprising versatility. It performed well in medical evacuations, troop transport, and low-altitude scouting. In areas where traditional helicopters struggled, this compact machine could sneak in and out with minimal sound. It hovered silently and landed in tight spaces, making it ideal for tactical missions behind enemy lines. For its size, few platforms offered more agility or practical use. Still, the Curtiss Z7 had limitations that halted widespread adoption. Its low speed left it vulnerable to enemy fire, and its short range prevented long missions. The exposed mechanics were difficult to maintain in harsh environments. While it never entered service, it laid the groundwork for multi-rotor flight control. Today, drone designers trace the roots of quadcopters to this strange flying skeleton. And speaking of strange, what came next flew with no wings at all. In the early 1980s, the United States tested an aircraft so strange, it looked like a sci-fi box with wings. The Northrop Tacit Blue was built to be invisible to radar, one of the first true stealth aircraft. Its curved, smooth body scattered radar waves, avoiding detection entirely. Powered by twin General Electric TF-34 turbofans, it cruised at 250 knots and flew at altitudes around 25,000 feet. The Tacit Blue's mission was to fly deep into enemy airspace, detect threats using onboard sensors, and send live data back without ever being seen. Its fly-by-wire system made it controllable despite its unstable shape. It had no sharp edges or flat panels. Every line was curved deliberately to reduce radar reflection, a revolutionary idea in Cold War aviation. Over 135 flights were completed in total secrecy. Test pilots confirmed its low observability and reliable stability during long reconnaissance missions. Although it lacked weapons, it was an airborne surveillance powerhouse. The air intakes and exhausts were hidden, further reducing its radar and infrared signature. The Tacit Blue proved that stealth could be aerodynamic and tactical. Once declassified in the mid-1990s, it shocked the aviation world. The Northrop Tacit Blue directly influenced the design of the B-2 Spirit bomber and modern stealth drones. It sits preserved in a U.S. Air Force museum as a symbol of engineering secrecy. But while America built a flying ghost, the Soviets were building something far louder, an airborne giant with the power of a train engine. In the late 1960s, the Soviet Union created a machine so massive it remains the largest helicopter ever built. The Mil-12 used 2 enormous transverse rotors, each over 115 feet wide, powered by 4 Soloviev D-25 turboshaft engines. With a total output of over 26,000 horsepower, it lifted more weight than any helicopter in history, nearly 130,000 pounds. Its scale was mind-blowing. The Mil-12 stood as tall as a 4-story building and stretched longer than most commercial jets. The reinforced frame and gigantic hydraulic systems allowed it to carry intercontinental ballistic missile components and large armored vehicles. Military planners imagined it bypassing infrastructure and delivering payloads directly to front lines deep inside enemy territory. During test flights, it broke multiple world records for payload and altitude. It lifted impossible weights to over 12,000 feet and cruised with precision. Despite its enormous size, pilots praised its control and stability in hover mode, but the logistics of operating such a colossus proved too demanding. Fuel consumption matched that of a small naval ship, and its unique size required custom hangars. Eventually, the project was abandoned due to cost and practicality. No battlefield required such extreme capacity regularly, and support infrastructure was nearly non-existent. Still, the MIL-I-12 became a monument to Cold War engineering ambition. Today, it lives on in museums and history books as the most powerful rotorcraft ever flown. But before we close, let's visit one last oddity, an aircraft that flew with no wings at all. In the early 1960s, American engineers built something that looked more like a bathtub than an aircraft. The NASA M2F1 was a lifting body, a vehicle with no wings that used its fuselage alone to generate lift. Constructed from steel tubing and plywood, it had no engine and had to be towed by a car or aircraft. But this strange little glider would forever redefine how spacecraft could return safely to Earth. The shape was the innovation. The M2F1's curved body redirected airflow to stay airborne without traditional wings. Designed for re-entry research, it simulated what future space vehicles might look like. Over 400 test flights were performed, and everyone provided crucial aerodynamic data. The glider handled more like a brick than a bird, but its descent was controllable and precise. Pilots described the experience as flying a controlled rock. The aircraft lacked conventional lift surfaces, but skilled handling allowed it to land like a sailplane. Each test pushed the envelope of lifting body design, with tows first done by cars, then by aircraft. Engineers gathered aerodynamic profiles for high-speed re-entry, low-speed stability, and glide path correction without parachutes. The NASA M2F1 paved the way for the space shuttle and modern spaceplanes. It proved lifting bodies could return from orbit safely without relying on drag chutes or capsules. Today, its legacy lives on in every reusable re-entry vehicle. With it, this strange chapter of aviation closes, a final reminder that in flight, even the weirdest ideas can change the world forever. Not every idea has to make sense to make history. Each machine you've seen today came from a wild vision and bold enough minds to test it. How many of today's failures will fuel tomorrow's breakthroughs? Drop your thoughts in the comments. What surprised you most? Watch the videos on screen now and keep exploring these aircraft that fascinate the world of aviation. Bye-bye!